NASA Tempo satellite to continue tracking pollution hourly from space until 2026. NASA's Tempo, tropospheric emissions, monitoring of pollution mission, launched in 2023, is revolutionizing how we monitor air quality. Tempo delivers hourly air quality data from 22,000 miles above Earth. Mission extended to 2026 after successful 20-month primary phase. Detects pollutants like nitrogen dioxide, ozone, and formaldehyde. The tropospheric mission of NASA was launched in 2023 to monitor pollution. It was abbreviated as Tempo and has revolutionized the scientists' observation of the air quality from space. It was located around 22,000 miles above the Earth, and it uses a spectrometer to collect daytime air quality data on an hourly basis over North America. It covers small areas within a few square miles and significantly advances technologies, offering only one-time readings per day. This mission was successful within 20 months at its prime phase from June 19, 2025, and is now extended till September 2026 because of the exceptional quality of the data. Tempo tracks the air quality. As per NASA, Tempo keeps a track of the pollutants such as nitrogen oxides, formaldehyde, and ozone in the troposphere, which is the lowest atmospheric layer. This layer gets triggered by the power plants, vehicle emissions, dust, smog, and wildfire smoke. It gives hourly data rather than once a day, said Laura Judd, a researcher at NASA. Through this, we get to know about the emissions change over time. Further, how to monitor smog in the city or wildfire smoke. Such a real-life incident helps astronomers understand the evolution of air pollution in detail. The major milestone during this mission was to get sub-3-hour data, which allows quicker air quality alerts. This enhances the decision-making and helps the first responders, said the lead data scientist at NASA's Atmospheric Science Data Center, Hazem Mahmood. With over 800 users, Tempo has passed 2 petabytes of data downloads in a year. It proves the immense value of the health researchers and air quality forecasters. NASA's collaboration with NOAA and SAO. NASA worked together with NOAA and the Smithsonian Astrophysical Observatory, the former producing the aerosol products for distinguishing smoke from dust and analyzing the concentration. As per Shang Liu, the principal investigator, these datasets enhance the forecast of pollution, improve the models, and support public alerts at the time of peak emissions. NASA's Earth Venture Instrument program is running the Tempo mission and a global constellation of air monitors, along with GEMS of South Korea and Sentinel-4 of ESA. The formal mission review this and evaluate the progress, inform future space-based air quality efforts, and be helpful in refining the goals. $88 million pollution tracking satellite missing in space. An $88 million, 65 million pounds, satellite designed to detect releases of the planet-warming gas methane from oil and gas production has been lost in space in a major setback for climate efforts. The MethaneSat satellite, which had backing from Google and billionaire Jeff Bezos, was launched only last year aboard an Elon Musk SpaceX rocket. It was meant to collect data for 5 years on sources of the powerful greenhouse gas, which is responsible for nearly a third of human-induced warming, to help curtail the worst offenders. The Environment Defense Fund, the GO which oversees the satellite, said that communication was lost 10 days ago and is currently undertaking an investigation into what happened. Methane is the most potent of the greenhouse gases, and although it does not hang around in the atmosphere as long as carbon dioxide, it is 28 times stronger over a 100-year period. Despite an international commitment to reduce methane levels by 30% by 2030, year-on-year it continues to rise with the target unlikely to be met, according to the European Space Agency. The main sources of methane are from oil and gas production, farming and food decomposition in landfill. But many of the current satellites that monitor it are operated privately, reducing transparency of who the worst offenders for methane release are. MethaneSat came after years of development by the NGO Environmental Defense Fund, EDF, and once launched made much of its data publicly available, allowing scrutiny by governments and scientists. It was backed by a consortium of tech giants including Google and billionaire Jeff Bezos, which together contributed $88 million to the project. The instruments used by the satellite are some of the most sensitive in the world, able to pick up much smaller sources of methane as well as super emitters. Improving the sensitivity is important for detecting releases from agriculture which are often much more diffuse than from oil and gas production. Likely not recoverable. Google said when it was launched it hoped its project would fill gaps between existing tools. The company was using its artificial intelligence tools to process the data and generate a global methane map. But after just a year in orbit, in what was meant to be a 5-year program, communication was lost with MethaneSat. The team at EDF suspect that the satellite has lost power and said in a statement that it is likely not recoverable. It went on to say that some of the software could be reused but said it was too early to comment on whether a new satellite would be launched. To solve the climate challenge requires bold action and risk-taking, and this satellite was at the leading edge of science, technology, and advocacy, it added. One of the other major publicly available sources of methane data is hosted by Carbon Mapper. One of its sources of data is the TROPOMI instrument aboard the European Space Agency's Sentinel-5P satellite. Although it continues to send back data, its 7-year program was meant to finish in October. It is unclear how much longer it can continue to collect information, further limiting global efforts to track the greenhouse gas.